Here we're going to do chapter 13 and lesson 13.1, talking about right triangle trigonometry. And so trigonometry comes from the Greek word meaning triangle measurement, and it can be used to solve problems involving triangles. And so we're going to look at, first of all, a trigonometric function is a function whose rule is given by a trigonometric ratio. And what that trigonometric ratio is it compares the length of two sides of a triangle. They use the Greek letter theta. Traditionally is used to represent the measure of an acute angle in a right triangle. The values of a trigonometric ratios depend upon theta. So here we have these the trigonometric functions. They're the sine function, which is abbreviated with sin, and it is defined as the ratio of the length of the opposite side of a triangle over the hypotenuse of the triangle. So here we have sine. Cosine is the ratio of the leg that's adjacent to the angle and over the length of the hypotenuse. And tangent is defined as the length of the opposite leg over the length of the adjacent leg. So we have them over here where we've got the sine of theta. You notice it's abbreviated as sin. And so it says the sine of angle theta is equal to 4 over 5. So if theta is right here, then the opposite side is 4 and the hypotenuse is 5, so it would be the ratio of 4 over 5. Cosine of theta is equal to 3 over 5. So if here's the angle theta I'm talking about here, then the 3 is the adjacent side because it helps form the angle with the hypotenuse. And so cosine would be 3 over 5, and tangent is opposite over adjacent, so the opposite side would be 4, the adjacent side would be 3. So we think about it as this way, is that the longest side is always the hypotenuse, and the angle that helps form, or the two sides that form the angle we're talking about, so in this case the side that's 3 and the side that's 5, those two are helping form the angle. So the side that's 3 is the adjacent side, and the side that's 5 is the hypotenuse. And so then the side that's across from that angle, in this case the 4, that would be the opposite side. So we say that the sine of theta is equal to opposite over hypotenuse. Cosine is equal to adjacent over hypotenuse. And tangent is equal to opposite over adjacent. And whenever you write the trig ratios, you always have to include the angle, whether it's theta or whether it might be, sometimes it might be x. But one way you can remember these is there's a little abbreviation that you can use for it. And it is called I don't want that smiley face there. It's called SOHCAHTOA. And that's just the abbreviation that we have. Sine is opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent opposite over adjacent. Just an easy way to help remember them. So here they want us to find sine, cosine, and tangent for this right triangle. So it'll be sine of theta, and you've always got to put that theta there. Too often students want to just put sin. And so since the angle is between the sides, it's formed by the sides that are 24 and 25, the 24 would be the adjacent side in this case. 25 is the hypotenuse because that's always the side across from the right angle, and which would make the 7 the opposite side. And so since sine is opposite over adjacent, this would be 7 over, or opposite over hypotenuse, that would be 7 over 25. Cosine then is equal to the adjacent side then, which is 24 over 25. And tangent would be the opposite side from the angle, which once again is the 7, and the adjacent side is 24. Now lots of students will want to change these fractions here to decimals, but you're going to want to just leave them just like that. So those would be my answers here. Let's see that. Let's go one color orange, and we'll make that dashed here. So we've got these answers: 7 over 25, 24 over 25, and 7 over 24. Okay, here we're going to look at two right triangles that you've used quite a bit, and especially in geometry. We have they're special triangles, and we're actually going to be using them a lot in what we work on with our right triangles. They are a 30, 60, 90 right triangle, which refers to the angles, and the 45, 45, 90 right triangle. And with the 30, 60, 90 right triangle, from the 30-degree angle, we can see that the opposite side is 1, adjacent square root of 3 over square root of 3, and the hypotenuse is 2. With the 45-degree triangle, we have the two legs of the triangle are 1, and the hypotenuse is the square root of 2. So for the angles 30, 60, and 45 degrees, they've already given us the answers for sine here, cosine here for 30 and 60, and tangent here, and those are according to this special right triangle that we use quite often. And then for the 45, 45, 90 right triangle, here we have the sine is equal to 1 over the square root of 2, which we will always simplify it to square root of 2 over 2. And cosine is the same. And then tangent's equal to 1 because we have the ratio of 1 over 1. And we're going to be using these special triangles in solving equations, and then when we get to lesson 3, we're actually going to define something called the unit circle, and we'll be using all of those ratios in the unit circle. So the thing is that when we have a triangle that has 30, 60, 90 right triangles or angles, or 45, 45 degree angles, then we can always use these exact values for sine, cosine, and tangent. And with the angles are not 30, 45, or 60, then we have to use approximate values, and we'll round those to 2 decimal places, where these we're going to use the exact values when we can. So here we have a right triangle here, and they want us to find the value for x. Now, since they give us the 30-degree angle here, the side one of the things you might want to do, and we'll go ahead and do that, is label the sides of the triangle. So we know that the side that's across from the hypotenuse is, or the across from the right angle is always the hypotenuse. And then the side here that helps form this angle, so we have the side that's 74, the hypotenuse. So this would be the adjacent side because it helps form the angle, and then which would make the x the opposite side. So if I want to solve this triangle, then I want to use the right trig function. So since I'm trying to find x, which is opposite, and I know the hypotenuse, then I'm going to use sine of 30 degrees is equal to the opposite, which is x, over the hypotenuse, which is 74. So basically all I'm doing is figuring out, deciding which trig function do I want to use. And since I'm working with opposite and hypotenuse in this case, that would be the sine function. So I'll replace theta with the angle, and the opposite side is x, hypotenuse is 74. So then it's just a matter of solving this equation. So we're going to multiply both sides by 74 and find the value of x. Now, since it is a 30-degree angle, then I can go up here to this table, this chart here, and sine of 30 degrees is right here, and it says that's equal to 1/2. So we'll do 74 times 1/2. So x equals 37. And if it's units, make sure you have units there in your answer also. So we figure out, once again, we figure out what do we know. We know the 30-degree angle. We know the opposite side is x. Hypotenuse is 74. So we plug them into the correct trig function and go from there and solve it. Okay, now we're going to go ahead and look at an application problem of using the right triangle. And when we're solving these problems, we have to make sure that if we're not using a 30, 45, or 60-degree angle, we have to use our calculator with finding the answer. So first thing you want to make sure of is that if you look at this, this problem, it says that the angle we have that we're working with is 15.1 degrees. And so when I use my calculator, I need to make sure that my mode then, I go to check my mode, and mine's in radians. I need to make sure my mode is in degrees so that I will get the right answer when I solve it. So let's go ahead and look at this problem. We have a right triangle here. It says in a water skiing competition, a jump ramp has the measurements shown. To the nearest foot, what is the height above water that a skier leaves the ramp? So we need to identify these once again. Are we talking about adjacent and hypotenuse? We're talking about opposite hypotenuse or opposite adjacent. So we need to know which trig function we're using first of all. So if our angle is here, our 15.1 degrees is here, then this side down here would be the adjacent side. This H here, that would be the opposite. And once again, the side across from the right angle would be our hypotenuse. So since we're trying to find H and we know 19 feet, once again, we're going to end up using sine to solve this problem. So we have the sine of our angle, which is 15.1 degrees. So our angle always goes there, is equal to the opposite side, which is H, of the hypotenuse, which is 19. So we're going to solve this equation just like we did the one in number 2. Since we're trying to find the numerator of this fraction, we're going to multiply both sides by the denominator, by 19, which will then cancel these two out. So we're left with H on the right-hand side. And then I'll take my calculator and just type in my calculator. So we'll type in here 19 times the sine of 15.1. Okay, and that gives us an answer of 4.95. So that answer is 4.95, and this is in feet. But their question says to the nearest foot. So the nearest foot, this ramp is going to be 5 feet tall. 5 feet tall ramp. Okay. So in our application problems, just like the last one we did, we take our right triangle, figure out what parts of it we know. So we know an angle, and here once again we know the opposite and the hypotenuse. So we use the sine function to solve that one and to get our answer. Okay. And here our next example involves some geology, it says, geology application. And first of all, we need to talk about a couple of things that we'll be using here. And those are angle of elevation and angle of depression. Now, the angle of elevation means if we are looking out and up, we have the angle of elevation. So if I'm looking out this way and then up, I have the angle of elevation. And angle of depression, if I'm looking out and down, then we have the angle of depression. So out and up is elevation, out and down is depression. Now the one thing about this is, if you remember the study in geometry about alternate interior angles, these two angles are actually alternate interior angles, and so they would be equal in a triangle situation. So they end up being the same exact angle. So it just kind of depends on how you draw your triangle that you're working with that help you to solve the problem. So here we have a biologist whose eye level is 6 feet above the ground, measures the angle of elevation to the top of a tree to be 38.7 degrees. If the biologist is standing 180 feet from the tree's base, what's the height of the tree to the nearest foot? And so what we're going to do here is, the first thing is we're going to draw a triangle. So we want to draw a picture of our situation. So I have a right triangle here. And let me just get the triangle drawn here first. Okay, so there's my triangle. And it says that we have the biologist is standing 180 feet from a tree. So here we have this tree here. So here's green. So here's the tree, and it goes down here. And we have our biologist. He's standing here, over here. So there's his head, and a nice little stick figure biologist here. And here's his eye. So it says the biologist whose eye level is 6 feet above the ground. So we have a distance here of 6 feet. And measures the angle of elevation to the top of the tree. So the angle of elevation is starting here, looking out, and then up. So this is 38.7 degrees as he looked out towards the tree and then up towards the top. And he's standing 180 feet from the base of the tree. So the question is, what is the height of the tree to the nearest foot? So in this situation, we have to find this value here for the height of the tree. Here's our right angle. And then we're going to have to add this additional 6 feet here to represent the height of the person. So in this case, we're trying to find h, which h is the opposite side of our right triangle. So this is the opposite. And the 180 would be our adjacent side, because that's across from the right angle, so that would be the hypotenuse. So the opposite is h, and the adjacent would be 180. And so we're going to use the tangent function. So tangent of our angle, 38.7, equals the opposite, which is h, over the adjacent, which is 180. So once again, in solving this, we want to get rid of the denominator. So we will multiply by 180. And we'll take our calculator to do that. Say 180 times the tangent of 38.7. And we get 144.2 feet. So our value of h is 144.2. And the question is, to the nearest foot, how tall is the tree? So we need to add 6 to that because of the height of the man. So 150 feet is the height of the tree. All right, so make sure you include the description of your answer. So here, once again, first of all, we drew a picture of that showed us our example of our problem. And we have our tree and our person there. And so make sure that you identify then height, which is opposite, which is adjacent, which is the hypotenuse, so to make sure you use the right trig function. And so in this case, we were working with the opposite and adjacent, so we're using tangent. Okay, our last example for this lesson then involves the the other three trig functions, we've looked at sine, cosine, and tangent. The other three trig functions are called reciprocal functions. And they're called reciprocal functions because they are basically the reciprocal of sine, cosine, and tangent. So cosecant, the function cosecant, which is abbreviated CSC, is the reciprocal of sine. So where sine was opposite over hypotenuse, then cosecant would be the reciprocal of that, or hypotenuse over opposite. Secant, abbreviated SEC, is the reciprocal of cosine. So cosine was adjacent over hypotenuse, so secant would be hypotenuse over adjacent. And cotangent, abbreviated COT, is the reciprocal of tangent. So since tangent was opposite over adjacent, cotangent would be adjacent over opposite. So the easiest way to do these three is to set them up so that when I write them out, I'll always put sine and cosecant horizontal with each other, secant and cosine, and tangent and cotangent. So here we have a problem. They want us to find all the trig ratios for this right triangle. So we'll write them out what we want to find. We're going to find, set it up like a little table here almost, that the sine of theta equals, and then we'll put cosecant here because they're reciprocals of each other. So whatever fraction I get for sine, I'm just going to flip that over for cosecant. And cosine, set that up with secant. And tangent, and with cotangent. So let's go ahead and I'll go back here and copy our first chart we had over here. So I'm going to select just these three parts here, and we will copy and paste it over here so we can see them. Alright, so there we have sine, cosine, and tangent. Now we'll notice the first thing we'll notice is that there is no hypotenuse for this right triangle, so the first thing we've got to do is find that hypotenuse. So we're going to have to find that. We're going to use the Pythagorean theorem. So our Pythagorean theorem was a squared plus b squared equals c squared. So which one of these sides you make a does not matter, or b, so we'll just say that 70 squared plus 24 squared equals c squared. So we'll take our calculator, and 70 squared plus 24 squared, and that's equal to 5,476, and then we'll take the square root of that, and we get 74. So this is 5,476 equals c squared. So c, or the hypotenuse in this case, is 74. So we'll write that up here. Right. So then, to find our answers, okay, we've got sine is equal to opposite over hypotenuse, so we need to label our sides again. So let's go ahead and grab our red pen here to label them. All right, now in this case, here's our hypotenuse again, 74, across from the right angle. Now the side here is 24. It's helping make that angle, so that's going to be our adjacent side. And the 70, which is the third side, then is going to be the opposite. So we write our ratios. Sine then is going to be equal to the opposite, which is 70 over 74. And whenever you write these fractions, always reduce them to lowest terms. So 35 over 37. Cosine is adjacent over hypotenuse. That would be 24 over 74, or reduced to 12 over 37. And tangent is opposite, which is 70, over adjacent, which is 24, which is 35 over 12. Now then, to get the other three, cosecant, once again, that's just a reciprocal of sine, so I'm just going to flip that fraction over. Secant, reciprocal of cosine, flip it over. And tangent, cotangent, reciprocal of tangent, so we just take the reciprocal of that one. Flip the fraction over. So the other three functions, cosecant, secant, and cotangent, are actually pretty easy because of we just need to take their reciprocal functions and take the reciprocal of their answers to solve them.